Get ready to learn some physics. At this point, you have maximum potential energy. At this point, you have maximum kinetic energy. At this point, there are equal potential and kinetic energies.
Notice the skateboarder's velocity is greatest when the kinetic energy is greatest, and smaller when the potential energy is greatest. Notice how momentum is always conserved.
Here, Carl is in equilibrium.
Here, Carl is about to jump off the platform to his death.
It's important to note that the period of oscillation depends only on the length of the rope and gravity, not Carl's mass.
Ignore air resistance, like we always do. Inside Jesse's pogo stick is a spring. The force on the spring is dependent on K, the spring constant, and X, the displacement of the spring.
Notice how the volume flow rate always remains constant. As Danny puts his thumb over the hole, the area decreases, thus the velocity increases. So we didn't have a movable piston, so here's volume.
Because we didn't have a movable piston, we had the pressurized car.
You are about to experience a rare form of pressure. Peer pressure. Do it, do it, do it. Carl's pressure times the volume of the remote remains constant throughout.
The force of Danny's weight is equal to his mass times g, the acceleration due to gravity, which he is overcoming in this clip.
In mechanics, the normal force, Fn, is the component perpendicular to the surface of contact. For example, here you see the table is exerting a normal force on Jesse's back.
In this clip, there are multiple forces acting on the board as Jesse does the kickflip. First, there's torque. As Jesse pushes down on the tail of the board, there is torque being exerted on the board, which allows it to raise into the air. There is also applied forces as Jesse pushes with his feet onto the board, allowing it to flip. What allows his feet to stick to the board is the force of friction.
Observe how the skateboarder can adjust the applied forces to achieve the desired rotation. Remember, projectiles exhibit a parabolic motion while in flight, such as this basketball.
It's important to notice that these projectiles only accelerate in the y direction and have a constant velocity in the x direction.
Like always, you can ignore air resistance. Now see Jesse combine all of his physics knowledge to accomplish this experiment.